Hello, my name is Mark Rogge, and I'll be giving this lecture on the utility of biomarkers and pharmacodynamic endpoints in Phase 1 and Phase 2b studies. I've worked in the biotechnology field for nearly 20 years and currently lead the clinical pharmacology and pharmacometric organizations at Biogen IDEC in Cambridge, Massachusetts. The information and opinions that I'll present in this lecture are mine and may not represent those of my employer. Biomarker analysis and the attendant quantitative assessment, where dose, drug concentration, time, and other variables are related to changes in biomarker expression, have been at the core of biotechnology product development. Glycoprotein drug candidates often uniquely modulate a pathway in both selective and sensitive manners. With these pharmacological attributes, the drug development scientist has a tool, a special advantage that provides insight on mechanism of action, optimal dosing for various patient populations, and safety assessment. Let's go to slide 2. For this lecture, our time to discuss the utility of biomarkers and pharmacodynamic endpoints in these early clinical trials is limited, so we'll keep this discussion at an introductory level. However, I would like the listeners to understand that the full value of utilizing biomarkers in decision-making requires appropriate quantitative, statistical, and strategic considerations. We don't have time to discuss these considerations, but I would like you to appreciate a few key points. Biomarker data are generated for analysis that is then often used to make decisions. Data must become results that in turn become information for making those decisions. Understand the decisions that must be made and when they must be made so the appropriate biomarker data sets are generated, analyzed appropriately, and in the appropriate time frame. Also, another point that must be raised is the appropriate application of statistical analysis in the field of biomarkers. In particular, during later clinical trials, and when high-impact decisions are being made based on biomarker results, there must be some understanding of the validity of the biomarker findings. The power to detect differences from baseline should be known, and this requires a thorough understanding of baseline variability. The drug development scientist should understand how factors such as age, sex, severity and duration of disease, concomitant medication, and other variables affect baseline biomarker values. Without that understanding, it is not possible to determine dose response, duration of effect, significance of intrinsic variables such as body mass index, sex, age, or disease. These and other considerations are topics for future lectures. In this current lecture, we'll discuss the following topics: goals for the Phase 1b and Phase 2 clinical development programs. In very summary terms, the objectives and decisions for this stage of development. Definitions and characteristics of biomarkers. For this lecture, we'll focus primarily on soluble biomarkers and will not discuss imaging or genetic biomarkers since time is limited. General considerations when approaching the use of biomarkers. What types of biomarkers should be used? What caveats must be considered when using these data for making decisions? And finally, examples of biomarker use in early clinical development. We will use examples that illustrate the assessment and utility of biomarkers through proof-of-concept studies.